Hello, my name is Tiffany. I did the Engage and Explore section of our integrated STEM project for our lesson. It's titled Measurement and Movement of the Sun. And then the standards we picked were 1ESS 1-1. Use observations of the sun, moon, and stars to describe patterns that can be predicted. And then for math, we have two of them here. Tell and write time to the half hour and hour using analog and digital clocks, and then measure objects by using a shorter object end to end, and know what the length of the object is. Know that the length of the object is the same size objects that span inline up end to end. So these are the standards that we used for this lesson, just so you kind of understand where we're going with it. Um, so for me, this video is kind of just going to be a rundown of the Engage and Explore tabs. Those are the sections that I filled out, and that's just kind of what I wanted to do for my video. I thought that would be beneficial just in case there's any words or verbiage on here that's confusing. So before we get into the content of the lesson, the context is something that I kind of want to go over. So this lesson is a lesson that is going to take place throughout the day. So it needs to start in the morning because you're observing the sun and the placement of the sun. They need to be able to see where the sun is at in the morning. So if you have like a reading class in the morning or a reading lesson in the morning, um, you need to start your day with the science lesson if possible. If you need to get like permission, or like if I would need to get permission, I would do so. Obviously, before I just went and did it. Um, but anyway, regardless, try to get this part done sometime in the morning because it's kind of crucial for the entirety or like understanding of the lesson and as a whole. Um, so the time that you would use during reading would be replaced during your science time later. So whatever you didn't get done in reading class, you would finish later during the science time that you used. Okay, but anyway, so now that you know kind of what's going on, for the engaged part, this is what you would do right away in the morning. Um, it says that you should have previously talked about what was already in the sky, so students should know that the sun is something that's in the sky. Formally begin the class or the lesson by asking them what does the sun do that repeats, and then what do the patterns, what are the patterns. So students will do this with a partner. They'll discuss their answers, and then as a teacher, you'll be listening to their answers, and then you'll have an entire group discussion. I would probably limit the partner discussion to about 2 minutes and the group discussion to maybe 5, just to really manage time. If you think you need more or less, you can obviously work around or shift however you need to, but that's just what I would aim for. After your discussion time, so that should take like 7-ish, 8-ish minutes. Next, you're going to have students fill out this sun and movement worksheet. So you're going to have this printed out. It's going to be a physical copy with a pencil. The students will draw the sun in the morning, in the afternoon, in the evening, or like what they have observed in the past. So this worksheet is going to help you kind of gauge what they already know about the sun's movement and the sun's patterns. So that's what the purpose of that worksheet kind of is. And then I just have materials on this slide and then also the safety concerns. So yeah, and then you'll move on to the explore section after that. So this is all still in the same period of time. So I will explain this my digital science notebook when I get there. So don't worry about this right now. But for this section, the students will have a Chromebook, a plastic cup, and paper clips. I would give them maybe like 20 to 25 paper clips. They probably shouldn't need more than 20, I wouldn't guess. But I have not actually done this on my own, so I wouldn't know. Um, I have here with an asterisk. If schools don't have Chromebooks, they can definitely do this on a normal like printing sheet of paper. This was just kind of our way or my way of incorporating technology into this lesson. I thought it would be an interesting way to do so and fun. But over here on the right side of the page, I just have kind of instructions or kind of explaining how the lesson will go. This is kind of what I meant by the context of the lesson. And then I just have that make sure you give explicit instructions. This I thought would also be really good for um, like a substitute, just because I think it is very clear on what the teacher is supposed to be telling the students. So I just have examples here of like how should the kids walk with their Chromebooks outside? How should the cup look when they're supposed to be measuring the shadow? How should they be measuring with the paper clips end to end? So it kind of just shows that. And then um, once they're done measuring, they can go to this My Digital Science Notebook. So I'll kind of explain this here now. This is a slideshow from Slides Mania that I found that I thought was really cool. And so I wanted to incorporate it for the technology portion of this assignment. And so basically, what I noticed with my practicum is that my teacher during math had students, they had like a physical notebook that they would like paste in their notes or like handouts that their teacher would give them. So this was like my digital version of that. And so basically I just have one page in here and then it's like the like resources that you can use to make other slides. Excuse me. But this is the slide that I created for this lesson. So when they're done measuring, this box right here is where they would record the paper clips. And then once they're done measuring, they don't have to wait for everybody else. They can go ahead and like sit somewhere in the grass outside, or if you don't have grass on the concrete, I would try to maybe find somewhere soft if possible. But then tell them to describe the sun's position in the sky. So they're going to do that over here with these pictures. I looked these up just inside slides, and they can take them, drag them, and then resize them. I thought that first graders would be able to do this. Maybe I'm overthinking it or giving them too much credit, but I definitely think this is something that first graders are capable of doing. It shouldn't take them like a super long amount of time. But yeah, then they can drag over the sun. Um, Obviously, the sun will have to be in the front. This part might be hard anyway. I'm not going to waste my time looking at how to do it for you. I have an example made. But yeah, this is just what they'll make. And then I have on the slides that you can read if you want to, or you will have a copy of it, I guess. Um, but once they're done, everybody is done with this portion, the describing with a picture. You will take them back inside and then they are gonna record what the time of day is. So they're gonna do that by, I believe, this is just a picture of the slide. They're going to go inside and then I have these links here for analog clocks and then here's an analog. You can zoom into this and make it as big as you want basically and post it up on your whiteboard or your smartboard or whatever you would have in your classroom. And then you can also, if you go outside and come back in the next time, you can do a digital clock because one of the standards that we are using for math is that kids are able to tell time to the nearest half hour. So if this, for example, was the time that was up on the board, you would say, okay, so tell the time to the nearest half hour because it's obviously going to be closer to the nearest half hour. Or I guess like you could also have them do hour. It would be up to the teacher that is leading or teaching the lesson. For this, I'd probably have them do the nearest half hour. So for that, it would be 1:30 p.m. Help them find the right answer, and then they will again record it in that. They'll record it in this section right here of that slide. So yeah, and then this again just kind of describes the context. What else am I missing on here? I think that's about it. I just have materials and safety concerns listed over here. I do want to make note that you do want to make sure you tell kids like, hey, be careful. This is technology. It's expensive. Like we can't break it. just so that they do know like their responsibilities with their technology. And then just making sure if you do decide to use paper clips, I guess I should say that you don't have to use paper clips. We could use any coin basically. So quarters, pennies, dimes, nickels could be used. You could use pencils, basically any object that you would have in a classroom you could use for this project. I just thought paper clips were nice and small, and you could count a reasonable amount of them for first graders. Um, but yeah, so that is the end of my portion. I hope that it was all cleared up. I guess I'm going to add this because I just happened to see it. Um, I said that if you are a teacher that's going to incorporate this, or like if I was going to actually like incorporate this into a classroom, I would want to make sure to do it myself first so that I know what reasonable answers I should be looking for or listening for. So for example, here I have that the shadow shouldn't measure 165 paper clips. There's no way that a Dixie cup is going to make a shadow that large. So doing it prior, as a teacher will help you kind of know the ballpark of where reasonable students should be at, and they can't just try to have the biggest shadow. Basically, it's not a competition. They want to be accurate. Um, so yeah, I just thought I would add that extra note in there. I think it's important. But yeah, anyway, that's kind of what I did. I hope it was clear. I hope you enjoyed it. But yeah, so thank you for watching.